Students, I hope you all had a wonderful weekend. I got to talk to some of you over the telephone and by email. And I wish we didn't have to do this quarantine thing, but I just got to move onwards and forwards, I guess. We're on chapter 2, minerals, and what I'm going to do is I'm going to go over the 20 minerals, the 20 common minerals that you're going to look at in lab this week. And we're also going to go over what you need to do for this week's lab. First thing you might want to write this down here. The 20 minerals that I'm going to cover in this video that you need to get familiar with are fluoride. Let me see if I can get this bigger here for you. Let me get the bigger font here. Let's get it even bigger here. And sorry, it's kind of slow. Let me Lord. Format font. To get it bigger, it is Control plus. Okay, so I'm going to just do that a couple times. Okay, I hope you can see this on your screen. Here's the 20 minerals that we're going to cover. Fluoride, Muscovite, hornblende, Orthoclase, also known as Potassium Feldspar, Halot, Azerite, Quartz, Graphite, Gypsum, Pyrite, Biotite, Hematite, Olivine. I noticed that some people in the south call it Olivine. In the north, it's Olivine. It doesn't matter. It's the same thing. Olivine. Magnetite, Galena, Plagioclase Feldspar, Talc, Sulfur, Calcite, and Garnet. Those are the 20 minerals you're going to look at in the lab. There are more than 3,000 minerals known to science, but these are probably the 20 most common minerals. And if you understand minerals, it's going to hold you in good stead when we start talking about igneous, metamorphic, and sedimentary rocks, the three kinds of rocks, because rocks are made up of combinations of different minerals. So later on, we're going to look at rocks. We're going to try and look for the minerals inside the rocks. But on your upcoming lab, I'm going to send you an Excel spreadsheet that looks like this. And for each mineral, you're going to watch a video, and you're going to see 20 mineral samples, and they'll be labeled 1 through 20. And you got to figure out which of these minerals is which. For example, when I take sample number 1 out, you have to figure out it's one of these 20 minerals. And once you figure out what it is, then you can scratch it off your list. For each mineral, in order to identify the mineral name, you need to know the color of the mineral. So if I show you a mineral, you could tell me, is it pink, is it green, is it black, what color is it? Second thing you want to know is the cleavage. And what is mineral cleavage? Well, let's take a look. Mineral cleavage is the way the mineral breaks. If the mineral breaks in a predictable way, like this mineral here, you could see that if I hit this mineral with a ball peen hammer, it's going to break along these planar lines of weakness. It'll break right here, it'll break right here. So this mineral has cleavage, meaning that it breaks in a predictable way with flat planes. That's what mineral cleavage is. Here's another mineral, and you can see that it's got cleavage. It's going to break right here on this flat plane, and at 90 degrees at this flat plane right here, right here, and then right here. So it breaks at 3 different planes, each plane intersecting at 90 degrees. So we say this mineral here has 3 directions of cleavage. So if a mineral breaks in a predictable way with flat planes, we say it has cleavage. Let's take a look at the picture here. That might help.
All right, so the next 2 properties we're going to take a look at are luster and cleavage. Okay, now minerals, again, we'll display both of these. There are multiple systems out there that you'll find on the internet if you go look and search for them. However, for our purposes, we're only going to use, we're kind of going to invent our own. So first and foremost, what cleavage is in terms of minerals, it's basically locations or planes of weak bonds in which the minerals will break in a predictable manner. Okay. Now, there's going to be all kinds of different systems out there that geologists and other scientists use to rate to what degree the mineral will display cleavage. However, we're just going to talk about yes or no. Does the mineral display cleavage or does it not? So there are 3 ways that geologists will talk about it. Again, one way they'll break off into planes or perfect sheets. Perfect 2 ways means they break off into boxes, and 3 ways means they break off into perfect boxes. Okay. Here's a couple pictures of what that looks like. So again, all of these are examples of minerals that do display cleavage. Muscovite being one that shows 1 plane of cleavage, 2 planes of cleavage. Their example is feldspar. Again, another one that we use is gypsum. 3 directions would be halite, rock salt, and 4 directions would be something like calcite. I'll show you what that looks like right now. Okay, so again, what we have here, okay, are a couple samples. Now I'm going to pull this up and make this big so you guys can really see this. Okay. Now 1 plane, or this is an example of cleavage, and again, this mineral breaks off into flat pieces. This is actually a mineral, believe it or not. It's called Muscovite Mica. Breaks off into flat pieces. That would be an example of 1 plane. Okay. 2 planes would be like this, where it actually breaks off into perfect boxes. Okay, I'm sorry, this is 3 planes, excuse me. 3 planes where it breaks off into boxes. 2 planes would be calcite, something like this, where it breaks off into squished boxes. Okay, and so that's kind of the rating system that we use. Now another 2 plane could be, again, gypsum. If you notice, there's very predictable vertical pattern that this will break in. Okay, now again, the numbering system isn't something we're going to worry about. I want to know yes or no. So, for example, if I take a mineral from your kit and just say, all right, does this mineral display cleavage, yes or no? Your answer would more than likely be no. Something like this, does this mineral display cleavage, yes or no? And very clearly this has places and weak locations where the bonds will break very regularly. Okay, so that there is cleavage. Again, this guide kind of helps you take a look at it. If you want, you can use this in your notes as well. Okay, I'll pause it here and the video will end. If this is something you're interested in, you can have this copied down in your notes as well.
Okay, I think that guy, he did a reasonable job in showing you what cleavage is. So, once again, going back to our chart, first you determine the color of the mineral, then the cleavage, yes or no. So what you need to do is every time you look at one of the mineral samples in the lab video that I'll send you, you want to figure out, does the mineral have cleavage or does it not have cleavage? And if it has cleavage, it's going to break off in flat planes. And I think he did a reasonable job in describing that if it breaks off in sheets, it has 1 direction of cleavage. If it breaks off in boxes, it's 2 directions of cleavage, or squished boxes. Or if it breaks off into perfect cubes, it's 3 directions of cleavage. If you can figure out how many directions of cleavage it has, it'll make it easier to identify the minerals. But you have to, at least for the lab, you just have to say yes or no. Does the mineral have cleavage? Let me show you some minerals that do not have cleavage. So minerals with have no cleavage they don't break in a predictable way. This mineral here, quartz, has no cleavage. If I hit this with a ball peen hammer, you could not predict how it would break. So we say that it has no cleavage. And another way of saying no cleavage is it fractures. So here in this column here, you can say cleavage, yes or no. Does the mineral have cleavage? Try and figure that out. If you can figure out how many directions of cleavage, you can put that in the box below, if you can figure that out. Next thing you can use to identify minerals is hardness. And hardness, let me show you how what minerals have a hardness going from 1 to 10. And we measure hardness using Mohs scale. M-O-H-S, Mohs scale. And this is in your textbook, but here you can see Mohs scale here. Mohs scale is based on the relative hardness of 10 minerals. Talc being hardness of 1, the softest mineral. Diamond being the hardest, number 10. Corundum is 9, topaz is 8, quartz is 7, feldspar is 6, apatite is 5, fluoride is 4, calcite is 3, gypsum is 2. So let me ask you a question, see if you understand hardness. Would a topaz be able to scratch a gypsum? Yes, because it's a higher hardness, right? A topaz would be able to scratch quartz, feldspar, apatite, fluoride, calcite, gypsum, and talc. Would a talc be able to scratch a fluoride? No, because it's softer. It's got a lower number. So hardness is one thing we can use to identify minerals. Problem is we got this pandemic, so I can't send you the minerals for your lab because you got 17 different lab groups and we don't have enough supplies. So what I'm going to do is in the video I'm going to show you some things about the hardness. Now for hardness, all you got to do for this lab is say, does it scratch glass or not? Scratch glass. If it does scratch glass, write in scratch glass. If it doesn't scratch glass, I'm going to make this a bit wider, then you say does not scratch glass. Okay. You can go a step further if you also, for some of the minerals, I'll try and scratch with my fingernail. Now, the thing you want to remember is glass has a hardness of 6.5, whereas your fingernail has a hardness of 2.5. So if I could scratch a mineral with my fingernail, it has a hardness of less than 2.5. So that's also useful. So you could also, if you watch a video and I scratch a mineral with my fingernail, that means you write that down. Can scratch with fingernail. If I can't scratch it, you can say can't scratch with my fingernail. So that'll give you some more data. Figure out, watch the video and see if I can scratch a mineral with glass or I can't. And if I can't, then it's got a hardness of less than 6.5. If I can scratch it, it's a hardness of more than 6.5. If I can scratch a mineral with my fingernail, it has a hardness of less than 2.5. If I can't scratch a mineral with my fingernail, it has a hardness of less than 2.5. If I can't, it's more than 2.5. If I can't, it's less than 2.5. So what you're going to do is go through your mineral charts that I showed you in the last video. They're in your lab manual. They'll tell you the hardness of the minerals. And then if you figure, you can use what the hardness of the mineral. Can I scratch it with glass with that sample? Can I scratch it with my fingernail to narrow it down and figure out, can it be that mineral or not? Okay. Streak, S-T-R-E-A-K. Well, what is streak? Let's figure that out. Also in the video, I'm going to try and figure out streak. We have these porcelain plates. They could be either white or black in color. I'm going to scratch rub the mineral against those plates, and we'll see what color we get. That's the streak. Is it red, or is it brown? Is it blue? I'm gonna streak the plates for you, and you're gonna try and figure out what color is the streak. If any of you are colorblind, ask one of your lab partners to look at it for you in the video. Next thing is luster. Luster, the mineral is either metallic or non-metallic. So, a metallic mineral will have various characteristics that anyone can recognize. How do you know if something's a metal? Well, one thing about metal, what does this look like a metal here? This one right here? This one is a metallic mineral. Now, metallic minerals are usually shiny. Not always, but usually shiny. What else do you notice about this metallic mineral? Well, the mineral is opaque. Opaque. What's that word mean, opaque? O-P-A-A-Q-U-E. Opaque means it does not let light go through it. Metallic minerals never let light pass through it. The opposite of opaque is translucent. A translucent mineral will allow for light to pass through it. Let's take a look at what a translucent mineral looks like. Translucent mineral. This mineral here, it's not opaque. Light can pass through it. So we say it's translucent. Let me ask you, is this a metallic mineral or not? It's not, right? Because metallic minerals must be opaque. So metallic minerals are usually shiny. They are always opaque. Some metallic minerals, if they contain iron in them, will be magnetic. So if a mineral is magnetic, you know it's a metallic mineral. Copper, iron, silver, nickel, all the metallic minerals will also leave a dark colored streak when you rub it against a porcelain plate. And I'll do those tests for you during the video for the lab. So just pay attention and see what color, if you get a dark colored streak, if it's opaque, if it's magnetic, if it's shiny, it could be a metallic mineral. Non-metallic minerals are going to be translucent. They don't look like metals, right? Another thing about when you get the quiz and I send you some actual minerals to look at for the quiz, each of your groups is going to get 4 different minerals for the lab quiz later on. Some metallic minerals are heavy because metals are usually heavy, right? That means they have a high specific gravity. Okay, so minerals. We want to figure out what is its luster. Is it metallic or non-metallic? Okay. Special properties can include, does it react to acid? Is it magnetic? Does it have a high specific gravity? Is it translucent, opaque? And also crystal shape. Minerals are crystals. What is a mineral? A mineral is any substance that is naturally occurring, solid, crystalline. It means it's made of crystals. And it has a fixed composition, meaning that a mineral has to fit all 4 of these criteria to be considered a mineral. Do you think that a diamond made in the laboratory would be a mineral? No, because it's man-made. Do you think liquid mercury would be a mineral? No, a mineral must be solid. A mineral must have a fixed chemical composition, meaning it's always made of the same stuff. For example, quartz, the mineral quartz, is always made of SiO2. Two oxygen atoms bonded to a silicon atom. Doesn't matter where that quartz is from. It could be from Tennessee, Oregon, southern France, Australia. It's always made of the same stuff. One silicon atom bonded to two oxygen atoms. So minerals has a fixed composition. But a mineral must also be crystalline. And what does that mean? Well, that means that minerals grow into crystals. Some of them quite beautiful, like the ones you see here. Here's a beautiful quartz crystal. Quartz will always grow into a six-sided crystal. Problem is, not all minerals grow into big, beautiful crystals. Sometimes the crystals are too small to see. So, another example is garnet. Some of you might know about garnet. It's a mineral that always grows into a 12-sided crystal. A 12-sided crystal, which we call a dodecahedron. Don't confuse the crystal form with the cleavage. That's not the way the mineral broke. That's the way the mineral grew. See the difference? So if you look at crystals, if you can see if the mineral grew large enough to have nice sides to it, like these crystals, you could put that down in special properties on your answer sheet for your minerals lab. But if the minerals did not grow into nice big crystals, then you can't do that. But don't confuse the way the mineral grew versus the way the mineral breaks. The way the mineral breaks is cleavage. Okay? So once you go and you figure out color, cleavage, hardness, streak, luster, special properties, then you're ready to identify the mineral. And there's 20 minerals you need to identify. Once again, here's the list. And we're going to work our way down this list. And I'm going to show you a few things about each of these 20 minerals. Let's start off with the first one on our list, fluoride. So when you watch that video, one of the things you might see is fluoride. Here's some different fluorides. Now, the first thing I have to really warn you about is when you're identifying minerals, many minerals come in different colors. So you just can't pick up a mineral and go on Google and figure out what it is by looking at photographs, because the minerals come in so many different colors. So therefore, like this mineral here, fluoride, you can see that both of these are fluoride, but one's purple and one's green. How am I going to tell if the mineral is fluoride? Well, I'll give you a few hints here, and that'll help you for your lab assignment. Fluoride, if it does grow into crystals, is going to grow into an 8-sided crystal. Second thing that's going to help you figure out if it's fluoride or not. Fluoride will not scratch glass. That means it's softer than 6.5. And you cannot scratch it with your fingernail. That means the mineral is between 2.5 and 6.5, right? Another thing about fluoride is that it's translucent. It will allow for some light to pass through it. That's the first mineral, ladies and gentlemen, fluoride. Now we're going to look at mineral number 2. And that is muscovite. Here shows you some pictures of muscovite. Muscovite breaks off in sheets. So it has one direction of cleavage. It breaks off in sheets. It's flexible. It's very lightweight. Muscovite has one direction of cleavage. It's very weak. You could break it off into sheets. It will not scratch glass. Muscovite. I'm also going to tell you about some economic uses of these minerals too that you need to remember. Fluoride is used to make toothpaste, and it's used to in making steel and in steel factories when you're smelting steel. Muscovite is used as an electrical insulator. Next mineral we're going to look at is hornblende. Hornblende is black to blackish green in color. Hornblende will scratch glass. Hornblende is opaque. Hornblende, if you look real careful, you can see the cleavage on hornblende. See, look at this sample real careful. See these lines? Those are lines of weakness in the mineral. They'll break along that. The cleavage isn't really obvious, but if you look at it very careful, you can see straight lines going through it. That means it has cleavage. Hornblende. Next mineral we're going to look at is orthoclase, also called potassium feldspar. Now this one, you can use color to identify. It comes in different shades of pink, but it could be dark pink or light pink or medium pink. But potassium feldspar or orthoclase will always scratch glass. Is it opaque or translucent? It's opaque. Orthoclase is opaque. And if you look carefully at an orthoclase sample, notice those lines of weakness in the mineral. It has cleavage. Actually has cleavage in two directions. It goes this way and this way, so it would break off in boxes. So orthoclase has cleavage. Next mineral we're going to look at is, oh, and by the way, orthoclase, its economic use is it's used to make porcelain. China, like plates and saucers and teapots, etc. Halite. Next mineral is called halite. Halite. Many of you have had that on your eggs this morning. We call it salt. It's also used to melt snow. What do you notice about halite? Well, it's clear. But lots of minerals are clear, so we need to know more to figure out that this is halite. Does it have good cleavage? Does it break off in flat planes? Excellent cleavage. Look at that cleavage here. This way, and this way. So it's going to break off in cubes. It has three directions of cleavage. You can see it breaks off in cubes. Three directions of cleavage. It's opaque. Also, halite will not scratch glass. Will not scratch glass. So it has a hardness of less than 6.5. And you cannot scratch halite with your fingernail. Therefore, it has a hardness of greater than 2.5. Halite. It's translucent. Also, it's salty, but don't do this. Don't do the taste test when you get the minerals. If you think it's halite, don't do the taste test. Because people have been dropping hydrochloric acid on these samples, so you don't want to do that. It's dangerous. Next mineral is called Azerite. Azerite's a beautiful mineral. It comes in blues or greens or purples. It's opaque. It's used to make copper wiring or copper jewelry. It has copper in it. But the big giveaway is if you rub Azerite against a porcelain plate, a streak plate, it'll give you a light blue to light green streak. Next mineral. Let me see. For some reason my face isn't showing up here. Oh well, it doesn't matter. Next mineral we're going to look at is quartz. Now quartz comes in all kinds of different colors. So you cannot identify quartz by color. It could come in clear, pink, we call that rose quartz. Purple, we call that amethyst. Orange, we call it citrine. Gray, we call that smoky quartz. So how are we going to figure out if a mineral is made of quartz? Well, sometimes they'll grow into a six-sided crystal. But sometimes the crystals are too small to see with your eyes. How are you going to know if it's quartz? Quartz will always scratch glass. Quartz has no cleavage. If it grows into large enough crystals, it has six sides. It leaves you no streak, a colorless streak on a streak plate. You cannot scratch it with your fingernail. That's quartz. Next mineral we're going to look at is called graphite. I don't know why the video of me is not there anymore, but that's all right. Next mineral we're going to look at is called graphite. Graphite is grayish in color, and if you rub it against a piece of paper, it'll write, because that's what pencil lead is made of, graphite. It will write. Graphite is used to make lubricants, such as WD-40. It's also used to make pencils. It's opaque. Graphite. Quartz, by the way, what is it used for? It's used to make computer chips and glass. All your windows are made of quartz. Next mineral we're going to look at is called gypsum. Gypsum looks like this. It's usually translucent. It's not opaque. You can scratch it with your fingernail. Does it have good cleavage? Yes, you can see it has excellent cleavage. It breaks in a predictable way. See those flat planes? So gypsum has good cleavage. You can scratch it with your fingernail. It will not scratch glass. It's semi-translucent to translucent. Non-metallic luster. This doesn't look like a metal, does it? Gypsum is used to make drywall or wallboard. My son works in that business. Then, next mineral is called pyrite. Pyrite, it definitely has a metallic luster, doesn't it? Back in the 1860s, they used to call this fool's gold. I'm a lot older than I look. I was actually there during the gold rush in the 1860s. Later on, I fought in the War of Northern Aggression when the Yankees came down. I'm just kidding. Anyway, here you can see this. It has a kind of a brassy look to it. It'll give you a black streak. This is pyrite. Pyrite. Kind of looks like gold. It'll give you a black streak if you rub it against a plate. A streak plate. Next mineral is biotite. It has one direction of cleavage. That means it breaks off in sheets. But it's different than muscovite. It's black in color. Very weak. You could break it apart with your fingers. It's used as an electrical insulator. Biotite. Next mineral we're going to look at is Hematite. Hematite can be silvery in color, or it could be reddish in color. So it comes in silver to red in color, but it will always give you a reddish brown streak when you rub it against a porcelain plate. It's opaque. Hematite's opaque. It definitely looks like a metal. It is a metal because it gives a dark colored streak, so it's a metallic luster. Hematite. Hematite's used to make cars and airplanes, anything made of steel. Next mineral is called olivine or olivine. Olivine comes in various shades of green. So if it looks greenish, even slightly greenish, it's olivine. Olivine is a beautiful mineral if it grows into a crystal, but usually we don't have nice, beautiful ones like this. It costs too much money. But if it's greenish, it's olivine. Olivine's non-metallic, and it's used in electronics, including your cell phone. Next mineral is called a magnetite. Magnetite is black to dark gray in color. But the thing that stands out about magnetite is if you put a magnet on the mineral, it will stick to it. It's made of iron. It's heavy for its size, so it has a high specific gravity. It is opaque. Light will not pass through it. Magnetite. Next one's called Galena. Galena's chemical composition is lead sulfide. So it's used to make anything with lead in it, including lead fishing weights, for example. It's also used in by the military for explosives. Here you can see that it has good cleavage. Look how it breaks off in cubes. 3 directions of cleavage. Definitely a metal, right? Galena has a metallic luster. It's opaque. Light does not pass through it. And if you get one of these for the quiz, you could tell it's Galena because it's heavy for its size. Lead is heavy for its size. That means it has a high specific gravity. You would put that under special properties for your lab if you get one of those. That's Galena. Next mineral is Plagioclase Feldspar. Plagioclase Feldspar is different than Potassium Feldspar or Orthoclase because it is light. It's white to light gray in color. It also has good cleavage. Notice how it breaks off with 2 directions of cleavage. It's opaque. It will scratch glass. Both types of feldspars, orthoclase and orthoclase and plagioclase feldspar, will both scratch glass, meaning that they have a hardness of more than 6.5. And it's used to make ceramics and pottery. Next mineral we're going to look at is talc. 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 And talc is the softest mineral that there is. Talc comes in various colors from white to light gray to dark gray. But how can you tell it's talc? Well, one way you can tell is it feels like soap. So if you get one of those for the lab quiz, touch the minerals. It'll feel like soap. Color is not as reliable as other attributes. It's very soft. You could scratch it with your fingernail and you'll get a white powder. No matter what color the mineral is, you'll make a white powder. And If any of you are fathers or mothers, you know what that is. It's baby powder. It's very soft on your baby. Talc, T-A-L-C. It's also used in for men in shaving powder, for the old-fashioned shaving powders. Next mineral is sulfur. S-U-L-F-U-R. And sulfur is one of the rare minerals that you can identify by color. It is yellow. Sulfur is canary yellow, so that's going to be an easy one for you to identify. And it can be translucent or opaque, but you cannot scratch it with glass. It's used in to make explosives, and it's used in to make your car battery. Next mineral we're going to look at is calcite. C-A-L-C-I-T-E. Calcite comes in different colors, but the most common ones are clear, like this, or a slightly white. Here's an orange one here, but you can see it has good cleavage. Calcite has good cleavage in two directions. It will not scratch glass, and you cannot scratch it with your fingernail, meaning it's hardness between 2.5 and 6.5. Another thing about calcite is it will react when you drop hydrochloric acid on it. So when you watch the video, if one of those minerals reacts to hydrochloric acid, it's calcite. Calcite will react if hydrochloric acid is dropped on it. Another thing about calcite is if the calcite is opaque, and it's always somewhat opaque, and you put it on top of letters on a page, you can see that the words are doubled. That means it has birefringence. That's called birefringence. It doubles the letters. Birefringence. Calcite is used to make antacids like Tums and Rolaids. It's used to make cement and concrete. Next one is garnet. And garnet is one of the birthstones. It comes in different colors. You can see there's a whole bunch of different colors. It can come in dark red or ruby red or green. The most common colors are greenish to reddish in color, but it always has 12 sides. That's called a dodecahedron. That's its special property that make it easy to identify. It grows into 12-sided crystals. It will scratch glass. It means it has a hardness of more than 6.5, and it grows into 12-sided crystals. Last thing I wanted to focus on here before we call it quits tonight is when you study minerals, what people who study minerals are called mineralogists. And I don't know why the font went. Mineralogists. And what do mineralogists specialize in? Well, what geology is really about is money. I mean, that's the bottom line. And what mineralogists are interested in finding is ores. O-R-E. What is an ore, a mineral ore? An ore is a mineral deposit that can be mined for a profit to make money. And every object that in the room that you're now sitting in, almost every object contains minerals in it. Your cell phone, your computer, your television, your light fixtures, the tile on your floor, your air cleaner, your vacuum cleaner, they all contain minerals. So when a manufacturer needs access to these ore deposits in order to manufacture their products, and So an ore is any mineral that can be mined for a profit. Mining jobs in the United States provide a lot of high-paying jobs for young people, and both for the miners and the geologists, and make us competitive. We want to make things in the United States. We should buy things that are made in the U.S. because we keep the jobs in this country. Every time I buy something, I try to buy made in the U.S. because, as my father told me, if you don't, you're sending jobs overseas. Well, how are we going to compete with the rest of the world? We have to have access to ore deposits so that we can manufacture our products at a competitive price. Okay, I'll call it quits there, and I'll see you next time. I'll figure out how to quit here. Quit time. And